All right. Good morning, afternoon, or evening, whichever time you're watching this video. How's it going, Bucks? Right now I'm going to talk to you about homework number 6. Homework number 6. Going all over attributes of functions. So let's get started. Very first problem. Sarah, the yearbook editor, right, and Miss Moore, the yearbook sponsor, are reviewing costs to produce the yearbook. The yearbook design software that costs $300, right? We got a cost here, and it costs $15 to print each yearbook. Ooh, that's a rate, right? Don't forget that's a rate, right? And that's a one-time cost. That's an extra once cost, right? All right, so we got $15 each yearbook and an $800 cost for the software to be purchased at the very beginning. So let's have two variables in this problem. You can't really see this area. I guess I didn't do a good job of getting this out. But let's try this out. Let's see. I'm going to call number of yearbooks. Let's call it B for books, right? B for books. B stands for number of books, right? And we'll let C stand for the cost, right? Okay, so let's say they do 0 books. If they just print 0 books, it doesn't matter because they bought a software that costs $800. So they're going to pay $800 plus 15 times 0. Why? Because they didn't print. They did not print any yearbooks. So 15 times 0, but they did purchase the software. So 800 on his table, 800 times 15 times 0. Figure that out. Put it in the last spot. Keep on doing that all the way through with all these numbers. 15 times 1, 800 plus 15 times 2, right? 800 plus 15 times 10, right? Figure out what all of these equal. Go all the way down it. Keep on working it all the way through. I think you get the point there. And if you can't see that, let me just, if you can't see it, that was it for this one. Every single one of these, really, really easy, right? This one, this one, this one, this one, right? 800 times, 800 plus 15 times 0, 800 plus 15 times 1, times 2, times 15, so on. And you'll see the relation there real fast. Okay, finish off the rest of the table. The input variable, of course, was the number of books. That's your independent variable, by the way. And your output variable is your cost, right? Input variable is number of books B, and the cost is the output variable C. Write an algebraic rule that describes the situation. Well, as we look at this this table here, right? This table, notice how it always starts with 800 plus 15, but then just times the number, which that number is usually the number of books, and then it equals some kind of cost, right? That's your algebraic rule right there. I'm going to grab all that. Whoa, didn't want that to happen. Okay. Sorry, guys, a little tired. Grab that. Can't grab it. Okay, one at a time. And that's your algebraic rule, right? 800 plus 15b is equal to c. That's what it's doing every single time. Answer the following 2 questions. How much would it cost to produce 600 yearbooks? That 600 is books. 600 is going to go right there. Plug it in, find your cost. Find cost, right? Find C. Real easy substitution. And then backwards. This time, if they tell you 8,000, excuse me, for cost, the 8,000 cost is going to go where the C is. All right, plug it in there, and then you're going to work backwards. Find B. Find B. How many books would there be? All right, try that out. Okay. Determine if the relation's a function or not. Oh, way too easy. For tables, not a function. Let me write that down. Real easy how to do these problems. It is not a function, right? if the x repeats. Right? That's for tables. For graphs, use the vertical line test. Don't forget the vertical line test. Oh, let me finish this. The vertical line test tests to see whether it's a function or not, and it's used only for graphs. I can't write vertical line. Vertical line test. Once again, sorry guys, I'm extremely tired right now. So, say example, I had the C right here. Notice I draw a vertical line. It hits it once, it hits it twice. Once it hits that, then it's no longer a function, right? It should hit only once. Should only hit once. Right? Notice this one's hitting it twice, twice, twice. This is not a function. Try the next problem to the right of this problem. Let's keep going. Find a domain and range. Oh, that's way too easy. Domain is all the x's, and range is all the y's. So really easy. For the domain, just list the x's, right? List all x's. Just write them all right here. You know, literally, just look at those ordered pairs, write the x's. For range, just literally write the y's. It's that easy. Now to tell them whether it's a function or not, see the problem from before. See the table, right? Just check to see, does the x's repeat, yes or no? And that will tell you whether this is a function or not. Moving on, domain and range. Well, there's no numbers here, but all we got to do, say for domain, is look at your x-axis. It starts right here, which looks like about 1, 2, 3, 4. That's -4. I'm going to use that notation. Right, 2. The other one, 1, 2, 3. That's how far this gun goes. We're trying to see how far this thing goes, right? Where it starts and where it ends. It starts at -4 and it stretches as far as, looks like 3. All right. Now, let's look at this, the range. The range is looking at the y-axis, right? Starts here, ends there. Write it down here. Figure out the range. Oh, way too easy. Independent and dependent, which one? Oh, this is too easy, guys. Look at this. Oh, okay. How about this? I'll just give it to you. Check it out. Easy. The amount of money depends on the length of reception. The question is, which is the independent, which is the dependent? Well, guys, it tells you right there, the amount of money depends on the length of the reception. Money, M, money, right? M depends on R. So is M dependent or independent? Way too easy. Y'all got that. That was too easy to get to y'all. Let's look at the next one. See if that's any harder. Oh yeah, this is a little tougher. I like this one. Greg is making a costume for the play. Number of participants in the play determines, okay. Performance in the play, the amount of money material needed. Okay. The number of performers in the play or the amount of materials is needed. Which one comes first? Which one depends on the other? List it. See what you could do. All right. I want you to try both of those out yourself. You could do this. All right. All right, guys. That's it for this video. Y'all have a very good rest of the evening. I'm tired. See y'all.